Hey Calculus class! Tonight we're going to learn topic 49, direction, or otherwise known as slope fields. So a slope field can also be called a direction field, is a graphical representation of all of the solutions of a first order differential equation. It is not necessary to solve the differential equation first. So here is a visual picture of what a slope field looks like. You can think of it as a graphical antiderivative where each line, each one of these little segments, is a small tangent on the original function. So as you can see in this example, we can have multiple possible solutions to a differential equation. This would happen if you did not have the value for the plus k. So as we did a few days ago when you're solving a separable differential equation, or separating the variables, and when you combine the C1 and the C2, you get that plus k, and in some situations you're given an initial condition to find that constant. But if you are not, then on the slope field you have multiple different possible functions or curves that could be the solution to that differential equation. Whereas if you have a specific initial value where you can actually find k, then you have a particular solution to the differential equation and you have your initial condition. So you only get one specific curve on the slope field. All right, so now what we're going to do is we're going to practice sketching the solutions, because that can be kind of complicated. So we're going to sketch the curve through the point 0, -1 on this given slope field. So what that means is, and this does not have to be perfect. So what this means is that I'm going to have to put a point at 0, -1. So I'm going to start with the point right here. And you have to bear with me because I'm going to try my best to draw this via computer. And then you're just going to follow the direction of the tangent lines. So you want to make sure that you're kind of, when you sketch the curve, you are brushing as best as you can up against these tangent lines so that when you are done, it should look like a curve that follows the direction of the slope field. So there's the real one after my sketch. So the sketch doesn't have to be exactly perfect. You just want it to get as close as possible. All right, so now I want you to try and sketch the curve through the point 1, 1 on this given slope field. All right, so let's see how you did. If you sketched it appropriately, your curve should look like this. Notice that I start by putting the point on 1, 1, and I'm following the direction of the small little tangent lines as best as I can. All right, now how do we create a slope field? So you will be given some differential equation, such as dy dx equals x plus 1. And you'll be given what I call dot paper, which will help you draw a slope field. And the best way to do a slope field is you're going to want to create a table. And you want to create a table for the values of dy dx, because what you're going to be sketching is small little tangent lines that have that slope as their value. So at each point, we're going to sketch a small tangent line that has the value of the slope, or the value of dy dx. So when I create my table, notice that my differential equation only has the variable x in it. So that's why I have an x and not a y here. And then of course the value of the slope. So that means at each x value where there's a dot, I'm going to find the value of that slope at that x value. So in this particular case, I am going to find the value of the slope from -3 to 3. So I'm going to put -3 in for x, so -3 plus 1 gives me negative 2. And then so on. Negative 2 plus 1 gives me negative 1. And I will keep going till I fill out the table. Now, once you have your table, this is where it can get a little tricky. All right, so the best way to do this is you're going to want a straight edge or a ruler with you. Because now what you're going to do, so at each one of these x values, you are going to create a small tangent line with that slope. And I always recommend starting at the point or points that have a slope of 0. So in this case, when x is negative 1, each tangent line has a slope of 0. So that means I'm drawing little horizontal tangent lines. So at each one of these points, when x is negative 1, I'm going to draw a horizontal tangent line. Now, I would recommend to use a straight edge. Unfortunately, while I'm doing this freehand on the computer, I will try to make it as straight as possible. Okay? Then you go ahead and go from there, and you can start with any of the other x values that you like. I'm going to start, now I'm going to do, at each x value that's 0, I'm going to calculate or draw a small segment that has a slope of 1. So to do that, we typically know the slope of 1, so if I was to draw the segment at this point, that means that I'm going to have to go up 1, right 1 for a slope of 1. And this is why you want a ruler. So you can line up those points that have that slope of 1, and then you can draw your segment that has a slope of 1. And then you do the same thing at each one of those x values, and so on. So you would keep doing that, so then when x is 1, you have a slope of 2. So when you calculate that slope, at that point, you would go up 2, right 1, and you should notice that the slope is getting steeper as I keep going. Now, okay, I'm going to give you a couple minutes to go ahead and use your ruler or straight edge to complete the slope field. So when you are finished, it should look something like this. Now, it doesn't have to be absolutely perfect. What the AP test will be looking for is the 0 slopes, so they have to be able to identify that. And they have to be able to identify that the slopes are increasing at the appropriate rate, at the appropriate x values or y values, or decreasing. All right, now when we have one where it's dy dx is equal to y minus x. So in this one, this differential equation is dependent on both x and y. So that means your table will need to include each point on the graph. This means your table will be much bigger. So here is my table, and I had to split it into 2 in order to fit it on the screen. So this time, since in my differential equation I have x's and y's, I'm going to have to find the slope at every single point that I have on my dot paper. All right, so I'm going to go ahead and fill out this table, and I'm going to have to list every single point that I have shown on this dot paper. So I'm going to start with -2, -1, -2, 0, -2, 1, and so on, until I have filled out every point that I'm going to calculate the slope on. So I'm going to first calculate the slope at the point -2, -1. So that means I want to find the slope of the tangent line that I will be drawing specifically at this point. So I'm going to put -1 in for y minus -2 for x, which will give me a slope of 1. So then I'm going to keep doing this for every single one of these points until I get all of my slope values. Now here comes the tedious part. Now I'm going to go ahead and taking my straight edge, I am going to draw each tangent line at each one of these points with this specific slope value. So I'm going to give you a few minutes to go ahead and do that on your own. All right, so when you are done, your slope field should look something similar to this one. All right, so this leads us into AP style questions, which we'll be practicing more in the next couple of days. So, shown below is the slope field for which of the following differential equations. So, how do you know how to figure out which one of these is the differential equation for this slope field? First off, if it was only one specific variable, so if the differential equation only had x in it, that means that at every single x value, the same x value would have the same slope. So when we are looking at each x value, does each x value have the same slope? No. So that automatically eliminates A and B. Now, if it was just dependent on y, that means each y value would have the same slope. And does this slope field for every y value have the same slope? No. So that automatically eliminates E. So I now know that it is definitely in terms of x and y. So I have choice C and choice D to choose from. Well, when I am looking at my two choices, I have x plus y versus x over y. And the good place to start is to figure out at which points do I have a slope of 0. Okay? And that means a horizontal tangent line. So if you notice, along this diagonal right here, I have horizontal tangent lines. So if I was to choose, say for example, this point right here, negative 1, 1, and if I was to plug that into choice C, negative 1 plus 1 does give me 0. And if I was to put it here in choice D, 1 over negative 1, that unfortunately gives me negative 1. So it's not choice D. So I now know it is choice C. All right. So here is a common open-ended type of AP question. So you are going to consider this differential equation, dy dx is equal to y minus 1 over x squared, where x cannot equal 0. On the axes provided, sketch a slope field for the given differential equation at the 9 points indicated. So notice it's 9 points, and those 9 points do not lie on x equals 0 because you can't have x equals 0. So I'm not going to draw any tangent lines on x equals 0. So I'm going to create my table since it depends on x and y, and I'm going to go ahead and list all 9 points, and then I'm going to plug in x and y into my differential equation to find the appropriate slope for each point. And you should get the following. Then you should take your straight edge and sketch the slope, each little tangent line, so that your final graph should look like this. All right, for part B, we want to find the particular solution of y equals f of x to the differential equation with the initial condition f of 2 equals 0. So this is doing the separable differential equations. So this is my differential equation. I'm going to separate the variables. So cross multiply and divide so that I get y's on one side and x's on the other. I'm going to integrate. And after integrating, I get the natural log of the absolute value of y minus 1 plus c sub 1 equal to negative 1 over x plus c sub 2. Subtract the constants, so I have one constant k. Typically at this point, you would want to plug in 2 for x and 0 in for y so that you can solve for k. So you can do that now. Or what I ended up doing is I went a little bit further to try to get y by itself by exponentiating both sides. And since I have exponents adding together, I can split it up. And since e to the k is some constant, so I'm going to let that be a equals plus or minus e to the k. And the reason why I have the plus or minus is because of the absolute value signs. So now I can get rid of the absolute value sign. So I have y minus 1 equals ae to the negative 1 over x. Now I'm going to go ahead and plug in 0 for y and 2 for x. Solve for my constant a. And I can simplify that even a little bit more. So I have that my constant a is negative e to the 1/2. So then I can write my final answer as such. And I could even simplify that even more by adding the 1 and adding the exponents. And then the last part that you will see on a lot of the open-ended questions for these is for the particular solution, y equals f of x, so what we found in part B, find the limit as x approaches infinity of f of x. So I am finding the limit of what I found in part B. So when I set this up, and I'm going to go ahead and plug in infinity for x, and when I do that, I'm going to get 1 over infinity, which is just 0. So I get 1 minus e to the 1/2. Well, I hope you enjoyed learning slope fields, and I will see you in class tomorrow. Have a good night.